In this video, we'll solve some problems involving Pascal's triangle. So in the first problem, we're going to look at how we can use Pascal's triangle to expand binomials that are not just powers of like a plus b or a minus b. So in the first problem we've got, we're asked to expand and simplify 7x minus 5y to the power of 4. Now, I know that if I expand a plus b to the power of 4, the powers of a will go 4, 3, 2, 1, 0, and the powers of b will go 0, 1, 2, 3, and 4. And also the coefficients are from the row number 4 of Pascal's triangle. So this is row number 1, row number 2, row number 3, row number row 0, row 1, row 2, row 3, and row 4. And if you ever forget that, a good thing to note is that this row corresponds to squaring a binomial. So that's something to note. And so here, if we want to raise a binomial to the power of 4, we have to go to a row that's 2 past the square of a binomial. So we would use this row here. So let's think about this. How is this useful? Like, how can I make useful use of the fact that these are the coefficients? Well, I have to remember that the powers of A count down and the powers of B count up from 0. And then I also have to be able to draw out Pascal's triangle. So I have to know what Pascal's triangle looks like and how to draw that out. And then from there, I can think about this as being equal to, I can think about this as 7x plus negative 5y all to the power of 4. And then I can think about raising a plus b to the power of 4, and instead of and I can think about 7x as a, and I can think about negative 5y as b. So when I go to expand this, I would have a to the power of 4, but instead of a, I've got 7x. So I would have 7x to the power of 4. And then my next term would be plus 4 times 7x to the power of 3 times b to the power of 1, which is just negative 5y. And then I would have plus, the next coefficient is 6. So 6 times 7x squared times negative 5y squared plus 4 times a, and a is 7x, times b to the power of 3. Well, b is negative 5y, so we'll have negative 5y. Plus negative, and that should be cubed. So times b cubed. And then we've got plus negative 5y to the power of 4. So all that we've done is we've just substituted 7x for a and minus 5y for b, and then expanded this, or use this, use the Pascal's triangle to expand this. Notice that we have a to the power of 4, or 7x to the power of 4, 7x to the power of 3, 7x to the power of 2, 7x to the power of 1, and then the last term would have a factor of 7x to the power of 0, but 7x to the power of 0 is just 1. And then here we've got the powers of negative 5y go in the reverse order. So we have negative 5y to the power of 0, negative 5y to the power of 1, negative 5y to the power of 2, negative 5y to the power of 3, and then negative 5y to the power of 4. And the coefficients go 1, 4, 6, 4, 1. So those are the coefficients from, or those are the entries from row 4 in Pascal's triangle. So now we can go ahead and we can work on simplifying this. The other thing to, actually we'll see this in a second. So 7x to the power of 4, well that would be we have to raise 7 to the power of 4, which is 2,401. And when we raise x to the power of 4, we just get x to the power of 4. Plus, well, let's see here. 4 times 7 to the 3 is, so 4 times 7 to the power of 3 is 1,372. X to the 3. Whoops. Okay. We missed something here. We've got 4 times 7 to the 3 times negative 5 is, let's see here, is going to be a negative number. Because here we've got a negative number raised to an odd exponent, which is negative. So this term is going to be negative. And we'll get that this is minus 6,860 times x to the power of 3 times y. And then we've got plus, let's see, 6 times 7 squared times negative 5 squared. So we've got 6 times 49 times 25, which is 7,350. And notice that this term is positive because I'm raising negative 5 to the power of 2, which is going to be positive. And then I'll have x squared, y squared. My next term, because I'm raising negative 5 to an odd exponent again, is going to be negative. And then I would have 4 times 7 times 125 is going to be the coefficient. And if you compute that, you get 3,500. This will be, we'll have one factor of x, 3 factors of y. So we'll have x times y to the power of 3. And then the last term is going to be positive because I'm raising negative 5 to an even negative 5y to an even exponent. So I'll have 5 to the power of 4, which is 625, positive 625, y to the power of 4. Okay. So let's see. Are there any terms that we can combine? And the answer is no, because when I raise 7x minus 5y to the power of 4, I should get only. You'll only ever get one more term. You'll always get one more term than the power that you're raising that binomial to. So if you're raising a binomial to the power of 4, you'll get 5 terms. When we raise this binomial to the power of 5, we're going to get 6 terms. Because if you look in Pascal's triangle, for row number 5, there's 6 entries in Pascal's triangle. And since all of the powers of the terms are going to be different, you're going to have no like terms to combine. So let's go ahead and we'll expand 3x squared plus 2y to the power of 5 next. So here we have that, let's see here, this would be equivalent to, and here we have to go to the row number 5 in Pascal's triangle, which has coefficients, let's see here, we have coefficients 1, 5, 10, 10, 5, 1. So this is row n is equal to 5. So I know that my coefficients, let's see, my first term is going to be 3x squared to the power of 5. My second term is going to be positive, so I'll have plus 3x, whoops, I have to get my coefficient from Pascal's triangle. So my second coefficient is going to be 5. And then I would have times 3x squared times 2y. And then I would have plus 10 times 3x squared to the power of, oh, you know what? Here, we made a mistake here. Okay, so this shouldn't be 3x squared squared. this should be 3x squared to the power of 4. Because the next term is just going to have a power of this, one less than the previous term power of this term. Okay, so this would be 3x squared to the power of 4. And then in the next term, we would have 10, plus 10, where we got that coefficient from this entry in Pascal's triangle. So we have 10 times 3x squared to the power of 3 times 2y squared plus 10 times 3x squared to the power of 2. Whoops, jeez. Okay. I need a lot more room here. Okay, here we go. We're almost done. So plus 5 times 3x squared to the power of 1. Oh, you know what? We missed something back here, too. Okay, geez. Sorry about that, guys. Let's see here. So let's see what we missed here. So we missed the power of 2y to the power of 3. So we should have times 2y to the power of 3. And now we can just go and copy and paste what we had before. And then we had plus 5 times 3x squared to the power of 1. But there's no need to write that power of 1 there. And we have to multiply that by 2y to the power of 4. And then the last term is just going to be 2y to the power of 5. And notice that here we have increasing powers of 3x squared. So this is 3x squared to the power of 5, 3x squared to the power of 4, 3x squared to the power of 3, 3x squared to the power of 2, to the power of 1, and then to the power of 0. And then if you look at the powers of 2y, we go from 2y to the power of 0, 2y to the power of 1, 2y to the power of 2, 2y to the power of 3, 2y to the power of 4, and then 2y to the power of 5. And now all that we have to do is simplify each term. So if we raise 3 to the power of 5, let's see what we get. 3 to the power of 5 is 243. So we'll have 243, and then we'll have x squared to the power of 5. Because we're raising a power to a power, we multiply the exponents. So we'll have x to the power of 10. And then we'll have plus 5 times 3 to the 4 times 2. So 5 times 3 to the power of 4 times 2 is going to be 810. So we'll have 810 times x to the power of 8 times y. For the next term, we'll have 10 times 3 to the 3. So that'd be, and then times 2 squared. So 10 times 2 times 27 times 4 is 1080. And then we've got x to the power of 6 because we multiply the exponents. And then we've got y to the power of 2. In the next term, we'll have 10 times 3 squared times 2 cubed. So we'll have 10 times 3 squared is 9 times 2 cubed is 8. So this will be 720 is the coefficient on that term. And then we'll have x to the 4, y to the power of 3. For my next term, I'll have 5 times 3 times 2 to the 4 is my coefficient. So 5 times 3 times 2 to the 4. Let's see, 2 to the 4 is 16. So we'll have 5 times 3 times 16, which is 240. So 240 times x squared times y to the power of 4. And then for my last term, I'll just have 2y to the power of 5. 2 to the power of 5 is going to be 32. And then y to the power of 5 is just y to the power of 5. Okay, so we can see that we can expand binomials such as this a lot faster using Pascal's triangle than using the distributive property. So it really helps to know Pascal's triangle when you're trying to expand powers of binomials.